Hello, hi to everyone. Today we will discuss limit cycle oscillation. Okay, so I think you know very well what is oscillation. Okay, the oscillation means oscillate between positive and negative values. Okay, so here we will see in the limit cycle oscillation what is that limit cycle oscillation. Okay, so during periodic oscillations, okay, the output of the system oscillate between positive and negative values. Okay, for increasing n, the output will become constant. We call that one as limit cycle oscillation. Actually, oscillation will occur during rounding off, especially while performing multiplication operation, addition operation. So we will get that limit cycle oscillation. Okay, so we will see one problem. Okay, so we will solve one problem, okay, related to limit cycle oscillation. This is the one of the problem. Okay, and LTI means linear time invariant system is characterized by the difference equation. Okay, y of n is equal to 0.87 y of n minus 1 plus x of n, right? Determine the limit cycle behavior and the deadband of the system when where x of n is our input of the system. Here the input of the system is 0 and y of minus 1 is 0.61. Okay, assume that the product is quantized, okay, to 4 bits. Here sometime in your problem they will mention the value of b, right? So you know what is that b, right? So binary number of bits, right? So might be, it may be an capital B or small b. What is that capital B? It is the number of binary bits. Okay, it is including sign bit. Small b is excluding sign bit. What is the equation for small b? Capital B minus 1. I think you know all those things. Okay, here they have not mentioned it is a small b or capital B. Okay, you can take either value of capital B or small b, but be careful while writing the equation of deadband, right? So there is a two different equation is there for dead band with respect to capital B or small b. Here we are considering the capital B, so I am writing the equation dead band by using the capital B, which is a number of binary bits including sign bit. Okay, so here my capital B is 4 bits. Okay, so by we have to round the, while doing quantization we have to round, right? So here we are rounding the bits for 4. Okay, so we will solve this problem. Just we have to consider our given equation in, so it is given in the problem, right? So this is our given equation, and then we have to write the, we have to solve this equation by putting the value of n0, 1, 2. Okay, we have to find out in which discrete time we are getting the output value same, right? That is that in that value, so we are getting in which value of n we are getting the oscillation or constant value. Okay, just first we are find outing the output of the system y of n. What is that y of n? Y of n is the output of the system for the value of n is equal to 0. Just you have to apply the value of n is equal to, we have to substitute in this equation, right? So thereafter you have to calculate the value of y of 0. So after calculate the y of 0, we will get the output, the value of y of 0 is 0.5307. Thereafter we are doing quantization, right? Here you know the method of quantization. First, for the given value we have to find out the binary values. You know very well how to find out the binary value for the fractional number, right? 0.5307. For example, so 0.5307 you have to multiply by 2, you will get 1.067. So first binary value is 1, right? So afterwards you have to do minus 1, right? Then we will get 0.0614, right? Again you have to multiply by 2, you will get 0.122. That second binary bit is 0, right? This is our first binary bit, this is our second binary bit. Likewise you have to find out the remaining values. How much we have to find out? You have another question, right? You have to find out up to 4 bit. Okay, there is a one reason is there. Okay, why should we have to find out the 4 bit? I will tell you. Okay, so after find outing the binary bits, right? So this is our sign bit. 0 is our sign bit. Okay, so 0.100. As it is fractional, we have to write in this format. Okay, 0.100. Okay, so thereafter we have to round for 3 bit. Okay, why means here I am considering the first bit, MSB bit, as a sign bit. So totally I have 4 bit. Okay, my capital B is equal to 4 bit. So here I have to round for 3 bit, right? So if you are just, you have to consider 4 bit totally, then you have to add plus 1, right? Originally 0.1000, right? So rounding means you have to add 1 bit for the fourth bit. So you will get 0.1001, right? Here we have to consider only first 3 bit, you have to omit this last bit, right? You will get 0.100. so if you are calculating the decimal for this number, okay, so how to find out that value? 0.1 means 2 to the power of minus 1, right? Into 1, right? 1 divided by 2 means 0.5. You know, our 2 inverse means you can write 1 by 2, right? So the value is 0.5. This is the quantized value of y of 0. Okay, next you have to find out y of n. The same method. Just you have to substitute the value of n, right? So n minus 1. N value is 1 year. Y of 1 minus 1 is equal to 0. This is x of 1, right? Here previously x of 0 is what? 0. They have mentioned in the problem. X of 0 is for any value of n. From n is equal to 0, 1, 2, 3. The value of x of n is 0. Right? So, nothing to worry about our input signal. Right? Just we have to find out the value of y of minus 1, minus 2, y of 1, 2, 3, 0, like that. Okay, we will see next one. Here our value is y of 0. We have already find out the value of y of 0. We have to take quantized value of y of 0. Okay, we have to take quantized value of y of 0. It is 0.5. Because after quantizing only it will compute the next value. Okay, so the quantized y of 0 value is 0.5. You have to substitute that 0.5. Okay, you have to multiply this 0.87 and 0.5. You will get 0.435. Okay, so again you have to find out the binary value. Okay, for this 0.435, then only you have to do rounding. That is, we are doing the quantization, right? So the same process, 0.43, just you have to multiply 2. Then you have to we have to find out the product of these two numbers. You will get 0.87. So the first number is our first binary bit, that is 0. Again you have to take 0.87 is multiplied by 2. So just do multiplication for these two numbers. You will get 1.74. So the second binary bit number is 1. So but here you have to do minus 1. So you will get 1 minus 1 is 0. So 0.74. Right? So again you have to multiply these two numbers. 0.74 into 2. You will get 1.48. The third binary bit is 1. Right? The process continues. Okay, so the afterwards again you have to consider these first 3 bits. Okay, consider first 4 bits. Okay, so 0.0110. Okay, so afterwards the just add plus 1. Okay, for fourth bit here add plus 1. So you will get 0.01 This is 0 point, sorry, 0.0111. Just omit this last bit because we are considering only first 3 bits. We are rounding, okay. So totally we have 4 bits. Our capital B is 4 bits. So if you are find outing the, this is our binary number. So if you are find outing decimal number, so this, the first bit is 2 to the power of minus 1, second bit is 2 to the power of minus 2, third bit is 2 to the power of minus 3. 2 to the power of minus 2 plus 2 to the power of minus 2 plus 2 to the power of minus 3. If you are calculating this one, you will get 0.375. Similarly, you have to find out y of 2, right? For n value is 2, just substitute the value of n as a 2 in the above equation, on the given equation, okay? In the given equation, you will get y of 2 is equal to 0.87, 2 minus 1 is 1, plus x of 2. X of 2 value is 0. So we have already determined the value of y of 1. Okay, what is the value of y of 1? We have to take the quantized value of y of 1, 0.375. So if you are multiplying these two numbers, you will get 0.32625. Again, for this number, you have to find out the binary number, binary bits. Okay. After that, you will get this binary bits. You have to find out the decimal value after quantizing, right? After quantizing, I mean after rounding, you have to find out the decimal value. Okay. So here, if you are doing the quantization, right? So you will get 0.011, right? How we got that one? So this is our binary bits for this number. Okay, so here we have to consider only first 3 bit. Okay, first 3 bit. Before considering the first 3 bit, first we have to consider first 4 bit. First 4 bits, this is the 0.101. First 4 bits, you have to add plus 1 in the 4th bit from, if you are considering like this, okay, then you will get plus 1 plus 1 is equal to 0. Again here we will get 1. You know binary add, how to add the binary numbers, okay, we will get 0.011. So this is our binary number. So then afterwards you have to find out this decimal number, right? So 2 to the power of minus 1, we have to neglect only 2 to the power of minus 2, plus 2 to the power of minus 3. So you will get 0.375. Previously for n is equal to 1, we got 0.375. For n is equal to 2 also we are getting 0.375. So for n is greater than equal to 1. So the output of the system is constant. What is that value? 0.375. We can limit here. No need to further find outing the value of y of 3, 4, 5 because we are getting the same value. Okay. So afterwards we have to find out the dead band. Here I have taken the capital B. For in order to find out the dead band, if you are considering capital B, means this is the equation. Okay, so plus or minus 2 to the power of minus capital B divided by 1 minus modulus of A. Here our capital B is 4 bit. Here A is the constant value. It is given in our equation. This is our value of A, 0.87. Okay, just substitute that those values in this equation and find out the values of dead band, that is plus or minus 0.48. So that's all. So this is our final conclusion. When n is greater than equal to 1, the system enters a limit cycle. So we can also prove that, okay, where in which value we are getting the that constant value, right? So which is our constant value. Okay, how can, this is one of the proof we can verify. You can also verify in your exam also whether whatever I have determined the value of that output of the system, that is constant value, whether it is right or wrong. Okay, just you have to do quantization of 0.87. This is given value A into 0.48. What is that 0.48? That is dead band. This is your dead band. Just multiply these two numbers, you will get 0.4176 find out the binary value for this one. Okay, then do quantization, you have to do rounding, you will get 0.375. You can check it there. See here, for n is equal to 1 we are getting 0.375, right? So, and also for n is equal to 2 we are getting 0.37. So whatever we have determined, that value is correct. Okay, I think you are able to understand this problem. Thank you very much.